So calculus is the chapter which we are discussing. The last video we started by giving an introduction to functions, and in this video we are going to see what actually calculus means. So we from the beginning stage we are using calculus word, maybe from our 10th class, 11th class we are using calculus word, but what actually that calculus means, we would have studied differential calculus, integral calculus, vector calculus, but we are not very aware of what actually the calculus do. If you see, major part of our core study includes calculus, differential, integral or vector, whatever it is. We require major part of calculus in our study. So it becomes the integral part of engineering. Without calculus, engineering is almost not there. So half of the engineering is not there. So you need to understand the calculus very clearly. If you are very good at calculus, then almost many derivations, many formulas, many conceptual problems, you could approach it very easily. So what does this calculus means? Calculus is very simple. Calculus means understanding the things in small pieces. So calculus is classified into differential calculus and integral calculus. So I said, understanding the things in small pieces. Instead of, for example, you are having some big object or whatever, it based on your application. If your application is based on some fluids, some major part of the fluid, if you take a small fluid and if you see, that is also comes under calculus. So here whatever may be your desired area or your desired structure, instead of understanding it completely, instead of going through it completely, you will understand only small pieces. You will divide this into small pieces, and you will understand the change. What are all the changes which is happening in that small pieces. For example, let us consider an object like this. Instead of considering the complete object, I am going to consider a very small part of this object, and I am going to understand this clearly. I am going to understand everything clearly, and that step is nothing but differential calculus. We will choose a small thing, we will choose a small part of the complete structure. Of that small part or of that small piece, you will do some analysis. You will find the change, you will find the value for that small piece. And once after determining the value for that small piece, you will start to add everything. You will start to add all the small pieces, or in the other sense, you can directly sum it up, summation of all the small pieces. And that procedure is nothing but integral. So taking a small piece of whatever it is, small piece of some object, and analyzing it and understanding it is differential calculus. Once after analyzing it and understanding it, after that you are going to find it for the complete object, and that procedure is called as integration. I will give you a practical example for this. Instead of going through all this, there is a very simple practical example. Most of them would have seen this, I don't know whether you observed it or whether you compared it, but most of you would have seen this. During our childhood, maybe before 10 or 15 years, this pressure cookers and all not there, right? So we are not like, I'm talking about some 20 years before, consider that 20 years before, this pressure cookers are not there, so we won't be cooking. Present day we are cooking rice in our pressure cooker, right? So we can easily identify at what point the complete rice is cooked. Easily by using the whistle we can identify at what point the complete rice has been cooked. But if you go back to 20 years back, there is no pressure cooker. For example, your grandmother used to cook. How she used to cook? There is no pressure cooker, but still she has to cook, right? She used to heat. She used to keep the rice in a water bowl, and she used to heat it. She used to boil it. But how she determines that whether the rice is cooked completely or not? What she will do? She will take one piece of the rice. once after some particular time, some 15 minutes or 20 minutes after boiling the rice, she will take one piece of the rice and she will press it. If she presses it very smoothly, if the rice got pressed very smoothly, if that one rice is cooked perfectly, then she knows that all the other rice also cooked perfectly, right? Instead of taking every rice and analyzing it, she taken only one rice and she just pressed it, and just by pressing it she knows. She now knows this one rice cooked properly, so obviously the complete rice would have also cooked. That is what differentiation and integration is. Differentiation is nothing but the rice which she taken and she pressed it, right? She analyzed the only one rice, small part of the complete bowl. She taken only one rice and she pressed it and she analyzed it. That comes under differential calculus. After analyzing it, because of her knowledge, she knows all the remaining rice also cooked perfectly, and that comes under integration. You are analyzing a small part, and from that small part you are going to find for the entire complete object, or the complete thing which you are taken for analysis. So that is the major definition to understand it clearly regarding integration and regarding differentiation. Instead of confusing it more, it's a very simple thing to understand by using the rice example. How the one small pile of rice is changing. By using that change, we can find the complete change of the complete bowl, right? So we will go for this is what about the introduction for calculus, definition for calculus. We will go in depth about each and every topic now.